Hello and welcome to another session in mathematics. In this session we'll be looking at sorts. But before that, let us take a review of our previous lessons. Welcome back. In the course of today's study, we'll be looking at introduction to sorts, simplification of sorts, addition and subtraction of sorts. Okay, so let us start. When we talk about a sort, we are talking of irrational numbers. Okay, now in mathematics there are what we call rational and irrational numbers. Rational numbers and then irrational numbers. Rational number is a number which can be expressed as a ratio of two integers, let's say a over b. This is an example of a rational number. When we have 2 over 5, have 10 over 7, we have 12 over 13. These are all what? Rational numbers. Now, all integers and terminating decimals are also what? Rational numbers. But any number which cannot be expressed as a ratio of two integers is then what we call what? Irrational number. Irrational numbers are found when we try to evaluate roots of certain integers. Example, when we have root 3 is an irrational number. We have root 5, we have root 11. All these are what? Irrational numbers. Now irrational numbers of this kind are called what? Surds. Irrational numbers of this kind are called what? Surds. Roots such as rational numbers are not surds. Okay, so with this little idea, let us then go over to simplification of surd. Simplification of surd. Simplification of surds. Okay, under the simplification of surd, we should understand that surds can be expressed in their simplest form or as the square root of a single integer. When we have root q times root p is something as what? Root p q. Okay, and where p and q are what? Positive numbers. For example, if we have root 8 is something as root 4 times 2. Is that correct? And 4 times 2 will give us square root of 4 is what? Is 2 root 2, and that's just the answer. Okay, so if we have let's say 63, root 63 is just 9, root 9 times 7. 9 times 7 will give us 63, and square root of 9 is what? Is 3. We have 3 root what? 7. How do we ascertain that? Look at how we do that. To have root 9 times 7, that is equal to root 3 squared times what? 7. And I told us that whenever we have the square root of any number raised to power 2, that is the same number. If we have square root of 2 raised to power 2, the answer is 2. This square root will cancel this. This 2 will cancel this square root. If we have this square root of 2 raised to power 2, square root of 2 raised to power 2, 2 raised to power 2 is what? Is 4. Square root of 4 is also what? 2. So that's how we prove that. So therefore we have what? 3 root 7. Assuming we have let's say root 40. Root 40 is equal to root 4 times 10, where 4 is a perfect square. So perfect square here, when you take the square root of a perfect square, you have 2 and then root what? 10. Okay, so the ones that cannot be expressed further are the ones you leave inside the roots. Now if you are giving root 30 to express, root 30 is equal to root 30. Do you know why? When we want to express surd, we find first of all a perfect square that can divide that number. Perfect squares are numbers like 4, 9, 16, 25, 36, 49, 64, 81. How do you obtain this? 2 times 2 is 4, 3 times 3, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 36, 7 times 7 49, 8 times 8 64, 9 times 9 81, 10 times 10 is 100. So these numbers are called what? Perfect square. So when a number is given to you, the first thing you need to do, you first of all find what? The perfect square that can divide that number, and whatever it gives you as the value, when it divides it, then multiply it with the number. That's exactly what we did when they gave us root 40. What perfect squares can divide 40? I gave us perfect squares to be 4, 9, 16. 4 can divide 40, 9 cannot divide 40, 16 cannot divide 40. So 40 divided by 4 will give us what? 10. Is that correct? So we have square root of 4 times 10. Is that clear now? And that will give us 40. So then have 2 root what? 10 as our answer. But in root 30, just like I gave to us, root 30 has no perfect square that can divide. 4 cannot divide 30. Okay? 9 cannot divide 30. 16 cannot divide 30. So since there's no perfect square that can divide 30 without a remainder, therefore root 30 remains what? Root 30. In case you find this in examination. Okay? So let us go over to the addition and subtraction of surd. Addition and subtraction of surd. Subtraction of surds. Okay, let us start. If we have a problem like let's say root p into root q plus root r, we can express this to be root p times root q, which will give us root p root q. Then root p times root r will give us root p root what? R. Is that correct? Now the plus here means root p q plus root p r. This is one thing we need to bear in mind when evaluating what? Addition or subtraction of what? Surds. If we are given root 28 plus root 63, all we need to do here is to break this down to their simplest form, and root 28, you agree with me, is equal to root 4 times 7. 4 times 7 is 28, then plus square root of 9 times 7. 9 times 7 will give us 63. Is that correct? Now 4, the square root of 4 is what? Is 2. So we have 2 root 7, right? Plus, what's the square root of 9? 3. We have what? 3 root 7. Now they have the same base, which is what? Root 7 root 7. Therefore we can add them up. We then have 2 plus 3, 5 root what? 7. Now one thing we should bear in mind here is when a problem has the same roots, then you can easily do what? Add them up or subtract them. Okay, as long as they have the same base, add or subtract. Okay, so we have number 2. Assuming we are given root 128 minus root 8. Okay, how do we express this? Let us start. 128 is equal to 64 times 2, and 64 is a perfect square. Remember, 8 times 8 is 64. Then we have a minus 8 is equal to 4 times 2, right? So square root of 64 is 8. We have 8 roots 2 minus square root of 4 is 2. We have 2 roots 2. Now they are of the same base, which is what? Root 2. So we then have 8 minus 2 root 2. 8 minus 2 will give us what? 6. We have 6 root what? Root 2 as our answer. Is there any problem with this? Okay, so to refresh your memory of what we've done so far, kindly provide the answer to the following questions on the screen. Welcome back. So far we've been able to deal with the introduction of surd, and we've dealt with addition and subtraction of surds. So we'll stop here today. I hope you really enjoyed the class. Do well to use the lesson note on the platform for better information on the topic we've just discussed, and feel free to leave your comments or questions on the comment section. Till we meet again in our next class, stay safe and bye.